All right, everybody. I'm hoping that the Ed Puzzle video was a great just review on homeostasis. We talked about that earlier, but I want to get into more specifics about blood pH because that's really what we're talking about, right? We're talking about the respiratory system, but we're kind of also connecting that with the circulatory system and how both of those systems work together to help maintain homeostasis, especially considering the pH of the blood. So I know this kind of requires a little bit of a chem review, and you might have said, Miss P, chem was crazy. I can't even remember what I ate last week, let alone what I learned in chem. So this is the pH scale. I'm going to cover that so you don't see three of me, right? I don't really need you to remember this by heart, and you don't have to worry about where it says moles. I do want you to know a few things, though. First off, you should know that the pH scale goes from 0 to 14, right? With 7 being neutral. So we know that 7 in the center is neutral, okay? 0 is super, super, super acidic. 14 is super, super basic or alkaline. You can use either of those terms. It means the same thing. Now, one thing you might not know is you probably just thought, okay, I know these numbers, Miss P, 7's neutral. Yeah, I got that. Okay, 6 is a weak acid, 8's a weak base. All right, I know this. One thing you might not know is that it's actually those numbers are based on a logarithmic scale. Okay, you don't need to worry about the math part. But what it has to do is it has to do with how many H plus or hydrogen ions are actually in that substance. So we know that if we're looking at something with 0, we should have a significant number of H plus or hydrogen ions. Whereas if we're looking at something that's basic or alkaline, we're going to have very, very little because we're going to have a higher concentration of something called OH negative or hydroxide ions. Now, if you're at pH of 7 and you're neutral, they're balanced 50-50, so to speak. Okay, just a reminder of what that is. So a few things that we should look at here. So if we're looking at blood pH, this is kind of showing you that scale. Again, remember alkaline and basic or base, same idea. So human blood actually should be about 7.4. So it's not exactly neutral. In fact, very few things are, even pure water, even water sometimes is not exactly at 7. But we know that this is slightly basic, right? And that's what we want. If this changes, that's not good in either way, right? If we get this to be moving towards neutral, that's not good. If it becomes too alkaline or too basic, that's not good as well. So what happens is your amazing and wonderful circulatory and respiratory system work together to get this pathway through. Now, I'm hoping, again, that when you look at this image and you see blue and red, you know that that's just representing something. So think to yourself, do you know what that represents? Okay, you should have said blue represents blood that's deoxygenated or oxygen poor blood. Okay, red represents oxygen rich blood. And if you have a hard time forgetting that, just look at the arrows. Red is going in. That's because there's oxygen when we're inhaling the atmosphere. Now, you know this isn't pure oxygen. There's nitrogen and all those other things in there as well. And blue is us exhaling the carbon dioxide. So this just shows the flow, okay? This is showing the pathway of how these things are flowing. Do I need you to memorize this? No, I just wanted to show you to remind you of this pathway. So let's look at specifically what's going on in the respiratory system. So when you look here, we know that the alveoli, those little grape-like sacs at the end of the bronchioles, those are going to have capillaries, and that's the site of gas exchange, okay? So here's your alveoli. This is a super magnified view. You have this capillary on the outside. You know that this is only blue because it's oxygen poor. It's going to go, it's kind of rubbing up against the alveoli. Carbon dioxide is going to go in the alveoli. Oxygen that's in there is going to go in the bloodstream. And then that's going to go where? Where would oxygenated blood go? In this case, it would go to the heart, right? On the left side of the heart to make sure that it gets pumped to the rest of the body that needs oxygen. Okay, so I'm hoping the homeostasis video helped you. This was just a quick recap video to help connect all of these things for you. And I hope you're having a lovely day. I will see you all later.